All right, so the next number system we're going to look at is binary or base 2. With binary, we only have 2 digits, and it's either a 1 or a 0. Now, this is especially important when it comes to computers. In a computer chip, the thing that makes your smartphone run so fast, there's a series of circuits. And inside the circuits, either they're off or they're on. And so the computer reads those off and ons in terms of ones and zeros, and that's the whole world around us is this base 2 idea. All right, so just like we did with base 5, let's look at how to convert a base 2 number into a number that we understand a little bit better. So 10111 in base 2, we'll convert that to base 10. Okay, so let's start with the furthest out. So this would be, this first position would be to the 1. This would be 2. Let's see, so 2 to the 0, 2 to the first, 2 squared, 2 cubed, and 2 to the 4th. Kind of translate that out. Okay, so 1 times 2 to the 4th plus 0 times 2 cubed plus 1 times 2 squared plus 1 times 2 to the first plus 1 times 2 to the 0. Alright, so 2 to the 4th is 16. Obviously 0 times anything is 0. That's 4 plus 2 plus 1. And so that translates into 23. So we are looking at the number 23 in base 2. Let's go the other direction. Let's look at 53. Let's convert that into base 2 terminology. And I think it helped to have that little list there. So 2 to the 0, 2 to the first, 2 squared is 4, 2 cubed is 8, 2 to the 4th, 16, 2 to the 5th is 32, and 2 to the 6th is 64. Okay, so obviously 53 is somewhere between 2 to the 5th and 2 to the 6th. So I want to know what power of 2 to the 5th would go in there. Obviously just 1. Okay, and then I want to look at the, let me write this a little lower here. So 1 times 2 to the 5th plus some power of 2 to the 4th. Well, let's take the 53 and let's subtract out the 2 to the 5th, which is the 32. And so that equals 21. Okay. So I'm going to look at my 21. I know I can fit 1 2 to the 4th in there evenly. So I'm going to take the 21 and subtract off 16. And that'll give me 5. Okay. So now I want 2 cubed. Well, 2 cubed is 8. 5 is already smaller than 8, so there's 0 2 cubes. 2 to the 4th, 2 squared, which is 4. Well, we can fit 1 in there. So there's 1 2 squared. So 5 minus 4 is 1. So how many 2 to the 1st are there? There are none of those, because my remainder 1 is already smaller than 2. And that just leaves me with how many 2 to the 0s are there, and there'd be 1 of those. Alright, so I'm looking at the things that I multiplied with. So in base 2, this would be 1 1 0 1 0 1. Again, base 2 would translate to the number 53. Okay, the last new numeration system we're going to look at is called the Duodecimal System. This refers to a 12-digit system. Okay, and in the 12 digits, we're going to use T to represent 10. we're going to use E to represent a group of 11, and then all the other digits are what we see. So in other words, the possible digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And instead of getting to 10, we now bring up T, and instead of bringing up 11, we bring up E. And then if I want to say 12, I just go to the next placeholder in the number. So let's look at converting this number from base 12 to base 10. So if I have E to T, what would that translate into? In other words, these are base 12 numbers. So this position, I'm going to scroll down here. This first position would be some power to 12 to the 0. This would be 12 to the first, and that would be 12 squared. So E would be 11 times 12 squared plus the 2 would be 2 times 12 to the first plus T would represent 10 times 12 to the 0 power. And then I just need to type that in a calculator. So 11 times 12 squared is 1,584 plus 2 times 12 to the first is 24 plus 10. And if I add that all up, I get 1,618. Okay. So that's what that translates into. Let's go the other direction. Let's just take a number. Get some space here. More space. Okay, so let's just take a number. Let's do something like 536. And let's translate that into base 12 using this new system. Let me write out our possible digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have 10, we have T, and E represents 11. Alright, and then let's just do a couple powers here. So we got 12 to the 0 is 1, 12 to the first is 12, 12 squared is 144, 12 cubed is 1,728. Okay, so obviously 536 is already 12 cubed is already too big, so we don't have to worry about that. So what I want to know is again, let me get some space here. How many times can 12 squared fit into 536? Right. So what's 536 divided by 144? And just go to a calculator for that. It goes in there 3 times, so it's 3 point something, right? So I know it can go in there 3 times. And so 144 times 3 is 432. And so what would our remainder be? That would be 104. Okay. So then I'm going to go to the 12 to the first power position. And I'm already looking at 104 versus 144, and let's see. So I know it can go in there a couple of times. So 104 divided by 12 goes in there about 8 times, 8.66, right? So I want 104 minus 12 times 8. And 12 times 8 is 96, which leaves me with 8 exactly. So it goes in there 8 times, and I have a remainder, oddly enough, of 8, and that, so 12 to the 0 times 8, right? So 536 in terms of base 12 would be 388, 388. Not 388 because that's assuming base 10, but 388 base 12 would be equivalent to 536.